Determine the left end and right end behavior and the horizontal asymptotes, if any, or slant asymptotes, if any, for f of x equals x to the fourth minus 1 divided by x squared plus 2x. If the highest power in the numerator is less than or equal to the highest power in the denominator, f of x has a horizontal asymptote. If the highest power in the numerator is greater than the highest power in the denominator, f of x has left end and right end behaviors of positive infinity or negative infinity. If it is exactly 1 higher, this will happen through a slant asymptote. F of x equals x to the fourth minus 1 divided by x squared plus 2x. The highest power in the numerator is a power of 4. Highest power in the denominator is power of 2. The highest power in the numerator is greater than the highest power in the denominator, but it's not 1 greater, so this will not be a slant asymptote. Instead, it will have left end and right end behaviors of positive infinity or negative infinity without going through a slant asymptote. These are determined by, for the left end, working out the limit as x approaches negative infinity of x to the fourth minus 1 divided by x squared plus 2x. And for the right end, limit as x approaches positive infinity of x to the fourth minus 1 divided by x squared plus 2x. Starting with the left end, the first thing to do is divide the numerator and denominator by the highest power of x in the denominator. That will be x to the 2. Each term in the numerator will be divided by x to the 2. Each term in the denominator will be divided by x to the 2. The first term in the numerator has 2 x's in the numerator. It can cancel with the 2 x's in the denominator, leaving x to the 2. The second term has no x's that can cancel or remain as a negative 1 over x squared. In the denominator, the first term, the x squareds fully cancel, leaving a 1 in the first term. In the second term, one of the x's in the denominator can cancel with the x in the numerator, and it will become a 2 over x. Each term that is a constant divided by x to a positive power will go to 0 as x approaches negative infinity. What's left over is x squared over 1. The next thing to do is try plugging in negative infinity in for each of the x's. Negative infinity squared is positive infinity over 1 is positive infinity. And the left end behavior is positive infinity. That'll work out the right end behavior. We will divide the numerator and denominator by the highest power of x in the denominator. That again is x to the 2. So in the numerator, we can divide the first term and the second term by x to the 2. In the denominator, the first term and the second term by x to the 2. In the numerator, the first term, 2 x's from the numerator can cancel with the 2 x's in the denominator, leaving an x squared. The second term has no x's to cancel, and will remain as a negative 1 over x squared. In the denominator, the first term, the x squareds fully cancel, leaving a 1. The second term, one of the x's from the denominator can cancel with the x in the numerator, leaving a 2 over x. Each term that is a constant divided by x to a positive power will go to 0 as x approaches positive infinity. The result is limit as x approaches positive infinity of x squared over 1. The next thing to do is plug a positive infinity in for each of the x's. Positive infinity squared is positive infinity. And there is the right-end behavior of positive infinity. The left-end and right-end behaviors match here because the numerator is exactly 2 powers, which is an even number, higher than the denominator. And that will make the left-end and right-end behaviors have the same sign of infinity. They both end up being positive infinity here.